Today we'll start with the adding root bone, but first of all, I need to kind of do best practices, and it's something that we're only loosely doing in class, but it's worth kind of ingraining into you, is that I'm sitting down at my workstation, and the first thing I want to do is, if I'm pulling a shared project, is I need to pull all the changes. And that's super, super important to get ingrained to your mind, is that when you sit down to work, you need to pull changes so that we have the most fresh version. I haven't been working on this laptop since last Thursday in class, and I've been working on my desktop on this project. I've slowly been incorporating the stuff you guys have been sending me, so we have a master project with everything added in. So just want to put it on tape, just bludgeon everyone over the head, sync your projects. You can also connect your Unreal project to version control inside the engine so that it's always warning you. It slows down things a lot because you have to imagine every time you open up a file it's to ping the internet. Every time you make a change, it pings the internet. It slows things down from laptops. Everyone's working on laptops. I'm not going to do it, but that's another way of having another level of safety, especially if everyone's not, right now everyone's kind of working asynchronously, but if we're working all same time in a studio, like sharing the same project, we want to make sure that we have the game synced inside of the software. So let's let it do that, and then we can let it hang. Let's see. I also want to make sure we're opening the project so it's not wasting our time later on. We'll come back. So, I think, Marcelo, you said you've rigged before, right? You rigged, and Eric, you said you had rigged before, or was it Stefan that rigged? Have you rigged a character before? You just like face stuff? Oh, I haven't done face stuff. I'd like you to show me that. Have you done it, and you've animated face? Oh, I totally need to learn that from you. I think we're gonna get some iPhones so we could do facial stuff in the spring. So what we're gonna do is we're gonna take an already rigged character, and I'm just gonna show you basically anything you bring from Mixamo, and this is how you make it a game engine asset. And it's like 3 steps. That's why I don't want to not include it. Great. So this is the female base mesh. And for historical context, the female and male base mesh were the first meshes that were involved, that were part of Mixamo when it first started, and they were the first 2 assets, and they removed them, and so I have like the archive of the first 2 assets. They're no longer there, and that's why I like to kind of use them. It's just historically, now you know the context. Right now, the root of the female, if I were to turn it into a wireframe mode, is right there. That is not the root. That is the hierarchy. The base of the hierarchy is this female base mesh hips. Because height. There you go. You get it out. And then we've definitely glossed over the fact that there is a hierarchy, and there are different kinds of bone naming conventions for these hierarchies. But a lot of people have been accommodating in Mixamo, and we've seen it propagate into Maya, Motion Builder, Simo 4D as presets. So it's pretty fun to stick with that. Unreal's using things instead of shoulder, it's using clavicle. Maybe a different kind of time, different era. That was cool. And right now what we have pre-pended is the word female base mesh. Does anyone know what that is called inside of Maya? That's called a namespace, right? So you can change namespaces, you can remove namespaces, and as you start working on more complicated projects, like we'll talk about workflow real quick, if you're doing retargeting in Motion Builder, you're going to retarget your motion to a character, and you're going to bounce that character over to Maya. You're going to retarget another character and bounce it over to Maya. In Maya, you might have a rudimentary, like a table and a chair, props that a character might touch, just so that you're making sure you're animating around these assets. But if both of them say female base mesh hips, it's going to offset the naming convention. It's going to get out of whack. So it's just, maybe it's more complicated than it should be, but I just wanted to let you know that you can actually change these namespaces by selecting the root and just going over to Windows and General, Editors, Namespace. And for the purpose of today, we're going to add a root bone, so I want to have no namespace to start off with. So I can select female base mesh and say, I do believe delete. Let's see. Let's say delete. And we'll say merge with parent. So there we go. You guys can see now, it just says hips, spine 1. There's no namespace there. If I were trying to merge in a root, I would have to add a namespace just to that one level, or I would have to, it's like we want to make it consistent. So this is good. We'll come back to this later to add a namespace, even though we don't need to for today's purposes. I just feel like it's good workflow to do this. So now we have our character with its hierarchy, And if I bring up the shelf for rigging, or if I go over here to rigging, like the second thing is just adding in a joint. And I'm just going to put it here in the center. Doesn't matter. I'm going to make it 0, 0, 0. Now it's zeroed out. I'm going to rename it root. Which, one thing of all the naming conventions, this is the only one I've ever seen named consistently. This one's always called root with a capital R. Now with root selected, I'm going to also control click hips. So I want hips to be connected to root, and I think I did it in the right order. And I can hit the P button. And now it's parented. Okay? And now we've created a root button and a root bone. You can see it right there. It's a little stick that's going up. And now it's a video game character essentially, and it's synonymous with almost any other video game character, and they can share animations now. So that's just a simple, quick trick that it was just really embedded deeply into YouTube. It's it should be way more on the surface and easy to do. So I'm going to go ahead and export this. I don't know if you guys have noticed, but my 3D Studio Max, they now have a game engine exporter. Always use this if possible. It's a little smarter about FBX file types than the regular FBX exporter. And then it gives us a smoothing group. You've noticed we imported Unreal. It says, you don't have smoothing groups. That's just it being a snob and saying, oh, so you don't use Maya, do you? And this is us using Maya, so we get rid of that little warning so it doesn't be snobby with us. And then I'm going to choose a folder, which for this project is in my Unreal projects. I'm lying. It's in my Unreal projects in this folder. And there we go. And I've created an imports folder, which I'm sure you guys have noticed. It was bloated the project a little bit, and this is going to be called, there you go, there's the folder, sorry, top, and then the file name is just going to be female base mesh root. Export, done. All right. Now, let's see, that's in the class form. Wow, the internet is at a crawling speed. I have to take my computer over the other side of the room. Anyway. That's fine. I'll just go ahead and start the project. Did it get the third person character in there? Yes, it did. We're going to fly by the seat of my pants here. And while we're at a lull, I'll go ahead and open up the max patch as well. Let's do the max patch. Let's do the max patch for now while we wait for this thing to finish syncing. Okay. Goes in the Slack, so we'll put it there. Alright, so while we wait for the internet to catch up with our blazing speed, we're going to show lists and max so that we can be prepared for when the project's ready to go. Alright, so everyone pretty much knows what we're here now. We have the audio reactivity, we're printing out values, we don't really have to, but we were sending single scalar parameters, and sometimes you want to send lists of data, like specifically an RG and a B, right? You want to be able to actually use a color palette or be able to send over different sliders to do an X, Y, and Z, and there's ways of parsing it. We kind of got into it a little bit in class when I was doing the screen recording at the end, and I was just pulling things off the data pin of the on OSC received instead of popping the floats. So let me real quickly show you to pack information. So we're going to use sliders to start off with first. We can always use a color picker if we wanted to, but I'll show you how to use just regular sliders. And a quick little trick here is that if you prefer horizontal sliders, you just drag it down here and it's a horizontal slider. So that's a cool little trick too, to your preference. All right, and each one of these is, I can print it out, but also another trick that we can add to the arsenal is if I use a message box, I can send this to the back of the message box, and it also is a way of like tapping into data. There you go. This is from 0 to 127. This is how MIDI values are sent out from 0 to 127. And we're going to convert this to a float. We're going to send this from 0 to 1. So we've already looked at that. That's a scale. I can steal this scale if I wanted to, or I can make a new one by saying new object by pressing N, scale. And it starts off with the input range, which is 0 to 127. And then we want it to be 0 to 1. There we go. And we're dealing with basically an X, Y, and a Z, or a R, G, and a B, and we can do it this way, and then we just need a few of them. There's also another thing called a picked slider, which is an X, Y plotter. That'd also be fun to use. Right? And that might be a little more intuitive than doing two sliders side by side. So maybe we'll do that for a second. I'll take these to the side. And we'll do this for X and Y. Alright, so this is 1, this is X, this will be Y, and this will be our Z. Alright? And we still need a scale for each value. So we'll put it in here to prove that that's your X and this is your Y, which would be on this side. Alright, so that goes that way, and that one goes that way. And we'll just put a few of these in a little cascade here. So we're taking each of these values of 0 to 127 and turning them into a float. And then from there we now have 3 0 to 1 ratios, but we need to put them together as a list. And that object is called a pack. It's actually called a POC, P-A-K. There is a pack, but it's not as useful because it's waiting for somebody else to send these bangs we've been talking about. This POC, P-A-K, is a hot object. Any data it gets, it's going to spit out in a list, so we want it to do that. We don't want to wait for the other ones to all send data and then send it out. We want it no matter where. If we're only sending out data from a new, like if I have 127 or if I have a 0.5 on one, I don't want to wait for it to change on all three values to send all three of them out. I want it to always just, if it's staying stagnant, keep on sending that same value out of 0.5 while the other ones are moving around. And we want to establish that it's floats, so there are your 3 floats. There we go. Let's make it bigger. There we go. And we now have a list. And this is exactly the same thing as prepending a single value, but if we now say new prepend, and now it's location, if we shut up this thing right here, send it over here, you'll see that we now have a list. A location, an X, Y, and a Z. And see, and I was trying to talk about being a hot inlet or cold inlet, like this is active. Even though these two aren't moving, it's sending out 3 values every time anything gets into it. That's why we're using this newer object called POC or P-A-K.
What kind of a slider is that?
This is called a picked slider. It's basically P-I-K-T. The reason why it's called a picked slider is that you can put a JPEG in there, or PNG, and it can be a picture slider so that you see what your axes are. You can also script it with JavaScript if you want to, so that it's interactive. All right. This is really cool for audio panning too. I mean, this is actually an audio panning tool for doing quad sound or 5.1 sound and going around a room. Cool. There we go. My stalling technique worked, and we've now synced, and we're going to open up Unreal and try to make this more coherent of a tutorial. All right. Kyle, Tumblr's already spamming me. It's come back to us. Your posts. Oh, it already opened up. Great. Okay. Cool. So let's go ahead and use this whole location thing since we've already put it together, and then we'll come back to the retargeting since we'll keep it in order. So what I basically have is something that's being sent on. It's sending 0 and 1 values on 3 different. It's like a vector, right? We're getting an X, Y, and Z, or an R, G, and a V. We could do either one. If I open up a new blueprint now, I'm going to go to my folders, or I'll just go into the main assets, blueprints. We'll create a new actor really quickly. And we'll call this one BP location. And what I want to do is I want the actor to drive itself around the room, and we have a little steering wheel inside of Max. So the first thing we're doing is we need to make sure that we have connecting OSC. That is our OSC receiver. And then just like we did overlap events by right-clicking and saying on event overlap and on event end overlap, we want to do on event oversee receive. So the same way Max get bangs, Unreal will get a tick every time it receives OSC, and we'll filter by address. The address we put in Max was location, which is right here. Let's also make sure that we send this to our UDP sender from last week. Cool, save. And then what is our address? Our address equals location / because it's internet protocol. That's totally not spelled right. Let's do that again. I have a bad habit of deleting everything if I just spell one letter wrong. It's such a waste. And then our conditional statement, right? This is a Boolean check for if it's location or not. If statement is called a branch. So if our location, let's go ahead and send some of this data. So if I put X on the channel X, if I put Y on the channel Y, I put Z on the channel Z, each one would come straight from this data. I'd be popping the float for one of them and looking for the channel X. I would then be pulling the data and looking on the channel Y, but I made a list. And I kind of started doing this last week, but I didn't really go through this process. So I've started a list now, and in the same way I'm packing things together, and it's seriously just the order in which I packed it. That's the order it is, and the order in which I unpack it. It's more like taking hats off the top of a stack. So I have, first of all, would be my X value that I was sending through. Then I'm going to, off that one, I'm going to pop the next value off, which would be my Y. And then the next one would be the Z value. And we're just dealing with list data here. Popping a float. And then we're going to make the actor move around, not a component within the actor. We're going to make itself move. So we're going to set actor location. And what is the target? There's no target, it's the self. I'm moving myself around. And we can either make a vector, right? We can make a vector and put these back together, right? Boom, boom, boom. Or we can split this apart and just drive it like this. And I think I probably, we're going from a thing I was labeling X, Y, Z, and of course Z is up in Unreal, so this will probably be a little funky. And it's also going to be kind of silly because Unreal units are centimeters, and I'd say this world is probably 500 by 500 centimeters, and right now we're going to 0 and 1. So we can do our scaling either way we want to do it. We can do it Unreal. Right? We can multiply each of these by 500. Or I already have an object over here for scale. Why don't I do it smart and just scale over here? Yeah.
Which one is less like computer power intensive? Which one would you recommend if we had something where it's like you could scale before or after?
It depends on how much time you have, but you always want to ultimately do it in the engine. I'm showing prototyping methodology, so I'm going to do it here because I don't have to compile and I can change numbers ad hoc. Max is, I'd say, probably if you're doing computations on a tick in Unreal, that's more CPU intensive. If you're doing calculations at 90 frames per second, if you're doing it versus doing it here continuously, if you're doing math, like complicated math. There you go. So I changed that. Of course, I could have overridden that. I could have scaled it to taste as I did it. And let's just see if this works. And of course, one of the things that we always forget to do is that we make these actors, they actually have to go into the world. Let's find a clean space. It's not relative position, so it's actually going to override to 0, 0, 0. So I can just go up to 0, 0, 0 for right now, which is way down here. And what's one thing that's going to be a problem with this is that we can't see it because we don't have any objects here. So let's add in a static mesh so we can see something. And let's find something wacky, like the Slender Man. That's not terrifying at all, right? Whose was the Slender Man? That was yours, right? Yeah, I fixed it up and it's in there now. Maybe a little big. There we go. So now this guy's gonna fly around and be a spooky ghoul. That's fortuitous. I hadn't planned that one out. There he is. Let's go ahead and rotate the other way. So I hit play. Hi, Slender Man. It's going to pop when I first hit the value. Oh no, it's not working. Alright, we're sending out values. That looks good. We're on location. It's going from 0 to whatever. What's our print say? We're going to debug together. This is always... This one's connected to scale. This one's connected to scale. Print is not getting anything. Alright, that's sending something. We see a move.
You were touching the one on the left. There's nothing plugged in the one.
This one right here.
You're using the one on the left.
Oh. There we go. Woo. Right? Obviously we have the mappings a little bit different, but yeah, that's pretty cool. Creating little, each one's inverted. Great, we're creating a little narrative. Now you can see why you do theater show control in these applications. Great. So that's working, and that's a list, and that's how you pack and unpack a list. Great. You just stay there and hang out, okay? All right. All right. I'm going to jump really quickly back to the retargeting thing. Let me import my female-based mesh that I made a root for, because this could be kind of fun too. And this is what I did with the inorganic kid character from 2 weeks ago. I put him into this before. So I'll make a new folder for female root, and I'll bring in that asset for my imports. And as is, I don't have any animations on this. So everything, like it says import animation, I don't have any, so I don't really need that. And everything else as default. import. And there we go. And we did this process a little bit in the last time, also I'll kind of go through it pretty quickly. I think it's going to be kind of funky, we'll see. So we need to, first of all, kind of tell these two skeletons, we need to create like a common language for them to share. And they both have different naming conventions. So we're going to kind of map them up. We're going to create a common rig called humanoid. And if I'm lucky, I can auto map. And some of these are okay. Most of these are wrong though. So hips, spine, and this is the tedious part of doing all this crap. So clavicles, left shoulder, yes, but left upper arm is not the pinky. That would be really screwed up if we did that. And trust me, I'll make a mistake on purpose, and it will be a little frightening. Right. Shoulder, upper arm is right arm. Lower arm is forearm. Again, we're just seeing how we mapped two similar skeletons. Right. Forearm. Right hand, that's fine. Neck is neck. Head is head. Thigh is left up leg. Calf is left leg. Left foot, that's right. Right is right up leg. Right leg, right foot. So this is technically at this point, this actually feels like it might be right. Base. But there's a thing called advanced that gets into fingers. If you really want to spend time and like make all the fingers match, and it's completely chaotic in here, and you're going to see the fingers are going to go all over the place. So we'll do that first, and then I said that it was a mistake, and we'll fix it, which is just a manual labor thing. So we're going to go over to the mannequin. Just real quickly, to take note that what is this position? The female base mesh is in. She's in a T pose, and our mannequin is in A pose by default. You usually model in A pose. That's more like natural, right? Everything falls more naturalistic. But when it comes to the weight mapping of like the underarms, it's a little funky. So we need to convert it. It's already been rigged. So once you rig it, then you can put it in a T pose. And I've already done it once, but if we come over here, we've already done the mapping. Go to skeleton, retarget manager, and it's already been mapped once to the humanoid rig. And then I've already modified it last week, but essentially I went over to the skeleton tree, and I was able to rotate the arms. That's the wrong bone. Upper arm, and I was able to put it into a T-pose, right? That was pretty straightforward. It was like 30 degrees here, 30 degrees there, and then rotated back the arm a little bit so that it wasn't, so it was all straight, right? Pretty much. I saved that down here as a pose, but now we can just view pose, right? I already saved it. This is the pose. It's T-pose. Hide pose, view pose. So I'm going to retarget to the pose. Before I get started with this, I'm going to save all. And now what we want to do is this skeleton has this whole array of animations, right? And all these animations are blending together with logic states so that I could drive them a third-person character. It even has this really cool blend space. I don't know if you guys have messed around with these, but if I click and drag, or as I hold shift, I can preview how these animations blend. See? That's a run, that's a walk, and that's an idle. And if you have a specialized character, you can actually go into Mixamo and download your own idle, your own walk, and your own run, and you just drop it onto those little dots, and it will change it so instead of the run being like this, it could be a witch riding a broom or whatever, and that'll blend naturally. So it's a really cool thing to switch those around, and if we have more time, we can get into that as well. So anyway, so I want to cheese off all this. I want to be able to take all these animations and retarget everything at once. These are all tied together into a new kind of blueprint we're not going to get into today called animation blueprint, which is all the logic that dictates animation. Right? This is like a state machine of different states you can have. And I just want to take all that and use it. So I'm going to find that animation blueprint, which is probably underneath animations. There you go. I'm going to take this, and I want to create all of these for my female-based mesh. So I'm going to click on Animation Blueprint and say Retarget. So I want to duplicate the Animation Blueprint and retarget it to another mesh. There's it. There's my female base. Why don't I see it? Yeah, we'll go for it anyway. I don't want it to be called third person. I want to remove the third person, and I want to put on female base, and then I don't want it to be in the root folder. I want to move it to a folder inside of my female base mesh. Boom, boom. I just don't know why it's not showing up. It's a little freaky. We'll try it anyway, though. All right, we'll just do it. Retarget. All right, it's a start. Oh, it wasn't showing it because of the errors. So now if we preview our lovely stuff, we can see that she's just having problems. Right? And that's just because all the other bones are like double mapped. And that doesn't often happen. I think it's just because I've been using this character for so long. It's like some sort of weird compression artifact. So, no harm, no foul. Let me get rid of some of this extra junk. I will delete what I just did. I'm just keeping everything tidy. I'll make a folder for animations. So let's do this one more time. That's better than making a mistake on purpose to prove a point, right? So let's put. Wait, where's her root? It's down there. Okay, so we got root, hips, all the other kind of stuff. That's great. And then we'll do the additional settings, which will show advanced. And then I could just say I don't care about fingers for right now and just X these all out. But if we wanted to be able to grab things, we'd have to fix that. Just don't double map things for right now. Groovy. I'm sure there's a unmap all, but whatever. Okay. Now let's save this. We'll save over the bone mapping for the we'll do a new one. Make some own. Save. Alright, let's try again. Back to the character, animations, do that, retarget, duplicate, and then choose female base root. And it shows up because they actually match now, and that's how I know I'm doing it right. Third person, we're going to get rid of that word, and we're going to make sure it says female root. And then let's put it in that folder we just made called animations, which was in our class folder, Todd, skeletal, female, and all that to just do this. Everything looks a lot better there. It's got a little funkiness. Basically, we don't want to retarget everything because they're not the same size. We want to just retarget based off the animations themselves. I'm going to show retargeting objects. And I think that I just want to say, where's hips? Root's down there. Root can stay, hip can stay, spine, let's say, I think it's, I forget which way it goes. I'm going to look it up real quick. I did it before with this other guy. It goes animation and the rest are on skeleton. Okay. So I want the animations to drive the main things, which are the hips and the shoulders, and the rest I want it just to look like, be natural to the skeleton. So I can say, come over to the spine 1, or spine, and say recursively, meaning going through all of them, change it to skeleton. And then on the shoulders, you can set this one back to animation. Animation. Save. And it'll look more normal. So if I go over to here, instead of being a skeletal mesh of male root, I could do female root. And then we need to use her animation blueprint that she has now, which is right here, which animation blueprint we're using. And we're using female. And there, we're ready to go. So any of your characters would work if you follow this process. You've now, got the beginning of a third-person character using whatever you make. So that's a cool little video game trick that I don't really get that much into, but I thought it was fun. And that kind of closes out 2 weeks ago where I was trying to do this before I left.
Cool.
So with the remaining stuff of class, just want to make sure I get into the spawning and destroying. Because we've already done the bone mapping and namespaces, we've already done push and pack, and then while spawning we'll get into dynamic instance stuff. So yeah, we'll cover everything. There's no real homework for it, just to kind of keep yourself abreast of all this stuff. So what we want to do is basically spawn things just like a particle system from a space inside this world. And for right now, I'm just going to do, I can do my pumpkins if we want to, right? So I have this pumpkin, and I've already made it a blueprint, okay? It's called BP Good Jack. It's got collisions, it's ready to go. It's even audio reactive. So what I'm going to do is I'm going to create a, just a volume, an empty space, and I could do this in my level blueprint, or I could do it in a class blueprint. I think I might, because of lack of time, I'll do it in a class blueprint, but we'll kind of combine the methodologies. I'm going to say new blueprint, BP spawner, and I'll put it into world, and I'm going to put it into world up high, into the sky. Let's open it up. And as I said before, we just want a range of space from which to spawn objects. We're going to do a box collision, something that will be invisible, and we'll make it bigger. You see everything I'm doing there, right? They correlate, and that looks good to me. We don't want it to have collisions though, because we're going to spawn. We don't want to get stuck inside of there. Overlap dynamic is fine. Cool. And you saw the object before. It's called spawn. Spawn an actor. And if you see here beside the spawn actor, you see how it has like a star and an asterisk. It's saying this is one of the most used functions in this entire game. There's like 5 things that are starred, and this is the one you use constantly when you're doing stuff. Spawning. Every time you shoot a projectile or fireball, or everything, these are all spawning. You don't want these things to be stored somewhere. They want to just come out of nowhere. So we're going to spawn an actor from a class, and we have a few things. We have to say what class that is. And as we talked about blueprint actors, is that when we're putting all of them into level, we're putting in objects of a class. That class is called BP Good Jack. So now we should have a pumpkin emitter. All right? So ready to go with the class. The next thing is the transform. And the transform is the same thing as like, this thing is called a transform. It's a location, a rotation, and a scale. So we want to have, let's say if we wanted the point to be right here, we could choose just, you could use a reference to this actor. Okay, BP spawner. We're going to bring in we're going to Oh, I didn't do it in a level blueprint. That's why I was going to do a level blueprint. So you could say the spawn is actually from wherever itself is. We're going to get its own get actor transform. Another star. So just spawn from myself. Spawn a good jack, and let's do it on the key of P. Input. To actually use the word P. All right. When I hit P, Jack's to come. One thing that we might want to look at with Jack is that is Jack dynamic? Will he fall? Well, let's first of all just make sure it responds. Looking up. No, let's see what's going on up here. Not happening. And that's why we that's why we prototype inside level blueprints, because key presses are not turned on for actor blueprints. You're supposed to prototype in your level. You don't want to have all these key presses all spread out through all these actor blueprints in your project, so that you have to then turn them all off later on. So by default, key presses are not allowed inside of actor blueprints. You can totally turn it on. Just go to these root settings and say allow input for player 0. And I've now like overridden the thing that they're trying to keep us from doing. And if I hit play, we now have pumpkins. We have the same pumpkin on top of itself. To prove that, go over to this outliner. We should have like a list of pumpkins. Or maybe just one. Where's BP Jack? Yeah, look at all these good jacks, right? As every time I hit P, I spawned it. It's still there. It's not destroyed. So that's forthcoming. It's not falling, and it's always at the same location. All right, so let's make it fall. We can do that inside of Jack. Let's use that reference. Open it up. And we want Jack to have... We want to keep them together. Oh, they can fall apart. That's fine. We want them to simulate physics. So now they have gravity applied. Actually, they don't have gravity applied because what I see underneath, well, let me see. Jack's top is 312 kilograms and Jack's bottom is 2,500 kilograms. And that's why I said it's important to model at the right scale, because a lot of the things we're like, why does it take us so long to import? Because it's doing things like calculating collisions and normals and mass. And you can always override it and check that box to give it an absolute mass. But we're going to go ahead and use the natural mass, and we're hopefully they'll fall, and the cap will fall off and roll, and that will be the ideal situation. So let's now hit play and hit P, and it falls. Cool. All right, that's pretty fun. Right, you can really see the difference in mass there, right? And if I was to do my frame rate, we'd see that it slowly, the frame rate would start dying because of it's a little intensive. Let's go running. Whee! Oh, come on! It's fall. All right. Anyway. Yay! All right. So I don't. My finger's getting tired, so I don't want to hit P anymore. I want to use the tick, but the tick, happens 90 frames a second or whatever. It's every frame. What's cool about that is that if you go to here to the self and you get the base properties of the class. Right here it says start with tick enabled, and the tick interval is set to 0. It means that the frequencies in seconds this tick function executed, if it's less or equal to 0, it'll tick every frame. But if it's actually a number, we've changed the definition of tick for this one blueprint. And now, and now we got to put a tick in there so that it's actually driving it. So instead of P, Let's use tick. And it should go every second. Pumpkin, pumpkin, pumpkin. Pumpkin, pumpkin, pumpkin. Pumpkin, pumpkin, pumpkin. Now, if you do a little beat detection inside of Max, you can set a little, every time a bass hits, it can drop a pumpkin, right? You can like have different frequencies sending out different, spawning different actors, spawning different things, right? That could be kind of cool. A little hi-hat sends out, something else like some leaves, and it could be some fun stuff there. But also, I'm not really digging how they're all coming from the same location. All right. So what I've done is I've made a box here, and I want them to be randomly inside of this box. I want to have like an emitter thing, right? You imagine you see how this is done in games constantly. So I want to change my transform. I want transform to be a range. What I'm going to do is I'll leave that over here. I want to get this box, and I want to get a reference to it, and I want to say get my box extents. It's getting the perimeters, the boundaries of my box, right? And then I want to choose a random point and bounding box. There we go. Get bounding box. Box extent. Where's the origin? So now what we have is a range, a random point within the box that's around the location. But how do we make a transform out of this? We come out here and say make a transform. And my rotation could be whatever, 0, 0, 0 is fine. My scale is at 1, just plug it in there. And now, it's raining pumpkins, hallelujah, raining pumpkins. Right? And imagine making this a game, right? Dodging pumpkins. Ah. Cool. So now, we understand the idea of spawning, but what's happening right now is that we have a garbage collection issue. There's two ways of dealing with this. One, so the function is called destroy. We've already talked about that, right? So one thing we can do is we can utilize the fact that we're using an actor blueprint, and we can make that blueprint work for us. All right, so what I could do, and in fact, let's just do that for today before we get into arrays, because I don't have time to really discuss arrays. Let's just do that real quick. So we'll go into old Jack. We'll open him up, and we'll just say, we know that when Jack spawns, it means that's his event begin play. He's born when he's being spawned. So on event begin play, we're doing these things. But what we can also do is do two things in one frame. We can say first set up as a dynamic material. And then on that same frame, but in this order, wait 2 seconds, and then commit suicide. Destroy actor. And which actor? I'm going to destroy myself. I know it got a little dark here at the end, but now it's doing its own garbage collection. Right? And therefore, it'd be the same thing as it falling out of screen. You can also put like a zone underneath, and they literally have a box that's called, and they're under volumes, that's called like kill zone, right? Kill Z volume or something. It just automatically kills things when it reaches a place that's out of the camera anyway. And that's something that's always used as a mechanic inside of video games anyway. So that gets us to spawning. We'll maybe add a little bit in for dynamic materials later on, because I want to spend a couple of moments just like letting people come up and ask questions. But that all makes sense. It's just obviously it's a bunch of new buttons you have to figure out where they are, and functions and get used to what they're called and how you can do them. But that's like getting us where we're going to go, is that we're going to basically create a scenario where I'm going to bring in some MIDI controllers, and we're going to learn how to make, like, basically each button can spawn any of these new objects we have, and I'll be able to allocate a new button and a new slider to every one of the assets you guys have, spawn an asset, spin it around at a different rate rotation, spawn an asset, spin it around, take it away, and figure out different ways of creating my own musical synthesizer based off all our assets so we can play along with the song. All right? Cool. So I'll end this recording, and then I'll stick around for a while so you guys can ask the questions.